What if you could build your own chat GPT for your PDFs using Amazon Bedrock? Look at this demo. I've built a complete rack system using Amazon Bedrock, ChromaDB, and Streamlit. So let me explain this rack flow using this diagram, because once you understand this, the code will make complete sense. So the point number one from here. Here our raw data is present, the documents, the PDFs, everything. And those PDFs are not directly sent to our LLMs. Those raw text, human readable text, are first converted into the vectors using this Titan embedding model and stored in this vector database, which we call as a knowledge base. What happens in this Titan model is the raw text is converted into the vectors, numbers, and then stored in this knowledge base. And next, from here, the user sends the questions to the LLMs, but the question is not directly sent to the LLMs. Instead, first, we retrieve the relevant context for that question. And how we do that? First, we convert the question into the embeddings using the same embedding model that we used here. And then, in this knowledge base, we do a vector search to find the similarity for that question and fetch the relevant chunks from that knowledge base. And we get a context for that question, and then we combine both question and context and send to that our LLMs. LLMs don't answer directly from their memory. Instead, they use this context and answer based on that context. So our result stays grounded and we get the relevant answers. So this is our complete flow. And now we will straightly move into the code section. So let's first create a virtual environment and then install this requirements.txt. So this will install all the required libraries for this demo. So these are all the required things for us. ChromaDB, Streamlit for UI, and Boto Core and Boto 3. These are the AWS SDK and AWS CLI and PyPDF to read the PDF data, because our data is present in this. Yeah, in data, Chroma, here will be present our collections that we will create, and in source data, here we have our raw data present. So this is one PDF file we have. And this is our ingest.py. Here we will write our ingestion code, however the data is added in our vector database. And rag app, this will be our front end, and raglib will be our retrieval and generation part. So all the required libraries have been installed now. Now we will write this ingest py. So in this, what we are doing is, so let me explain it from here. So this is our raw data present, and that raw data we are converted into the embeddings and storing in that vector database. That is what we are doing in this function now. So let's first import all the required libraries now. And then next, these are all the required libraries, that is OS, UUID, Boto3, ChromaDB, and this Amazon Bedrock embedding function and PyPDF. and then we are writing this function now. This is a function ingest. Here we are initializing a session, and then we are creating an embedding function using this Amazon Bedrock embedding functions. We are passing a session that we created here and passing a model name that will help us to embed the raw text into our vectors and a region. What I will do, I will not pass this region. And then next we are creating a ChromaDB client. For this client, we need to pass the chroma path. So let's first initialize that here. Chroma path and name for that now and we also need this collection name, and name of the chroma path will be this dot data slash this one. Here it is, data in chroma. In this chroma folder our collections will be present, means they are not at present. We'll create those collection in this location. And next we also name this need this collection name. And in this, here we are creating a collection. We are passing the name of the collection and an embedding function by which a collection will be created. And next we are writing another function, and that is load text files. What it does is it will go into this folder, this folder. At this folder all our raw data is present here, and it will go into that folder and take all the PDFs, convert into the texts, and then it converts them into the chunks and stores them into these folders, sorry, array called docs, metadatas, and IDs. Don't worry if you don't understand that. When we'll write this function, you'll get that clear. And next here we are debugging that. And if we don't get the docs, means any of the PDF file is empty, we will straightforward raise this error. And then next we will add that docs in this collection. So now we'll write our next function, that is this one, load text file. In this we are passing the location of our raw data, and next here we are creating this three arrays: documents, metadatas, and IDs. And then we are looping into the all the files inside this folder. In this demo we only have just single file, that is this. So we are looping into the all the files in that. And if the file is not a PDF, we are continuing that again. And then file path, we are taking the file path of this. And next we are reading all the text in that file and storing that in this full text variable. We have wrapped that inside this try catch block. So that is what we are doing it here. And next we are calling the strip function to remove all any leading or trailing white spaces. And next if that PDF is empty, straightforward we are printing this and saying that no extractable text and continuing it over here. And then the text we got, we are converting that long text into the chunks. Now let me explain it here briefly. What do I mean? So let's say we have a full text that we created here. That full text has nearly 1,000 of words, and now those thousands of words will be broken into some chunks. Say 200 will be a size of single chunk. Such five chunks will be created. That is what we are doing it here. I'll explain, and this is again a function that I'll write here. And once we'll get all the chunks, means we'll get an array of chunk. Say here we have created a if we have 1,000 words inside that, we'll get a 2,000 of 2,000 words a single chunk, which means we have five chunks now in this variable. And then we are looping inside that chunks array and appending that each chunk in this documents folder, sorry, documents array. That is what we have created here, that. And then a metadatas, in that we are adding an object source as file name, means the current file that we are looping in, this one. And a chunk id, that is this. And ids dot append, we are creating a unique id identifier for that chunk. And in this process if you get any error, we are straightforward raising this exception. And next, If the documents and metadatas and IDs length do not match, again we are raising an error. And then finally we are sending this all things back to this ingest function. That is what we are getting here. This doc metadata and IDs. Those has been sent from here. So now let's look into how this chunk text function is working. So this is our chunk text function. So here we are passing the text, and here these are the by default values. Chunk size will be of 2000, and overlap is 500. What do I mean by this is, each chunk will be created of size 4000, and then the next chunk will be created from 3500 to 7500. First chunk size will be 0 to 4000, and second chunk size will be 3500 to 7500. We are overlapping of 500 words between each chunk. That is what we are doing it here. And next, in this chunk folder, we are creating a chunks array. That is what this logic is doing. This what I have explained yet here. And finally we are sending a chunk. That is what we are getting it here, a chunk. And finally next processing has been done. And in this complete folder file, data has been how a data is ingested inside our vector database is been performed. So what we'll do is we'll run this function now. So let's call that ingest function first here, and then we'll write this function. In this chroma folder, collections will be created, and we got errors. Let's debug why we got this error. Ingest, okay, line metadata. Source docs. So there's a mistake in file naming convention. So let's come to source data. That is the name of that location. And now let's run it once again. We got 65 something. Maybe because here we are debugging that. Okay, each chunk will be created of 65. Okay, ingested 65 documents, collection count 65. Here we got a printing, and yes, our successfully collection has been created. This is that folder. And now we will look into this next folder, that is raglib. Here what we will perform is how data is retrieved and generated. That is what we will perform it here. So next, in our retrieval and generation part, so firstly we'll install we'll take all the required libraries for this, and then next, we are writing this function get rag response. In this we are passing a question. Now what this question is, this question is the one question that user is asking, the raw question that user asks. And then in this function we are initializing a session, creating a client, bedrock client. Let's don't pass a region. And then we are getting the collections that we already created at this location. We are passing the location of that collection here, and name of the collection as a legal docs. This was the name of our collection, and this is again a function. We'll write that function, and I'm printing that collection name here, and then we are doing a vector search in that collection. Again, this is a function will that will write. We are passing a collection name and a question, and we are doing a vector search over that. And whatever the search result will get, that will be our raw context. And whatever the result we'll get, that will be in this format. That is array of array. And that array of array we need to convert in this format. That is chunk array of chunks. That is what this flattened result list is doing. And next, the raw content we are initializing in this variable rack content. And next, we are calling this converse function, which is provided by a Bedrock, where we pass a model, LLM over foundational model. Any model that you want to use, pass the ARN of that model. And then messages is that this message, passing the role as user. Content is that the raw context. Then text, that is what we are passing is based on the above content. Please answer the following questions and the question that user has been asking. And then any inference parameter you want to pass. We have given a max token is 800, temperature and top p. And finally, whatever the result we'll get from our LLMs, we are passing that result and also the raw context. So next, we have this function that is get collection. So here we are passing the path and collection name. Again, we are creating a session, boto3 session, initializing a embedding functions, passing him the same embedding model that we initialized here. This one, Amazon Titan embed text, same model we need to pass it here also. And then next we are creating a client for ChromaDB, and then we are getting that collection from this location, name of that collection, and then passing that model embedding function name, and finally we will get our collection here. And then we are doing a vector search on that collection, and how that vector search is happening, here it is, passing collection name and question, collection dot query, and then query text the user question, and end results is equal to 4 means the top 4 matched results will be fetched from our collections. That is what this is doing, and finally we are sending that result, and rest part will be done by our LLMs. And this is how our retrieval and generation part is done. And next, in this RAG app we will write our Streamlit UI thing. So in this Streamlit UI, firstly we are importing the Streamlit and raglib, that is this sglib, and from this file we are calling this get rag response function, and in this function we are passing that input question, users question here, and we are getting the response content and search result, and those search result we are printing it here. Next we will run this file. So for that, Streamlit run rag app.py, simply hit enter. And before you run, you make sure that you add here a region, this region as US East 1. Why we need to do that? Because this model that we are using is only supported in that region. So we need to add a region over here. So make sure you add that region, and then run this Streamlit app, and then you will get this UI. And here you can ask the questions. And then simply hit this enter. See, whatever it is giving answers. See the informations provided about Octane financials, and this is the actual PDF that we have uploaded in our vector database, and these are all the information that it is providing us. It is summarizing all those information and sending us in a clean way that we can easily understand. And this is the search results that it is getting, all the top 4 rag. See here, this is a chunk 1, and next chunk 2, chunk 3, and chunk 4. Four chunks as we mentioned in our question. Four chunks as we mentioned here. Uh, Not here, but here. See here. To retrieve get vector search results, we said to fetch four chunks from the collections. That is what it is doing. See, I'm getting the complete brief of that PDF folders that we have uploaded. And yes, guys, and if you guys are facing any issues, make sure you have your AWS account created and your terminal is configured with your AWS account. And if you want to check that, you can use this command, that is this AWS STS get caller identity, and you can hit enter. I'll get this output because I have already done that. If you don't get this, which means your terminal is not connected with your AWS account. Make sure you connect your terminal with your IAM users. And yes, guys, if you found this video helpful, make sure to like and subscribe because it really motivates me to make more such content. And all the code sections will be given in the description. I'll attach a GitHub repository over there. You can find all the code sections and all the resources over there. And like and subscribe for more such content. And I'll see you in some other video. Till then, bye bye.